Okay, so let's start running the IPython notebook again. So I just go to my repository, and I also start my virtual environment where I installed IPython notebook or Jupyter notebook. And then I can start it. Okay. All right. So last week we covered the loops like while loop and for loop, and we also covered what break means or continue means, and also pass, which actually doesn't do anything. So we were left off with a few little things about the loops. So one of them was the nested loops. If you want to use like for loops, so if you want to iterate over an item inside, so an item which is also an iterable or which is also sequences. So for example, in this case, I have these two lists. So items is one list, which actually has like string and number and tuple and also another float number. And test is another list where the first item is a tuple and the second item is a float number, right? So let's say we are actually looking for the common elements between these two. So let's say you want to iterate over both of these. So you can run first for loop where it looks for all items in test. And then second for loop that actually looks for the items in items. And then if they are equal to each other, we actually want to say, okay, so what we are looking for, the equality condition is satisfied. And we say, okay, print. And then we say break. We don't want to continue. So let's say we are sure that there's only one item which is common between those two. And once we are done with it, we say break, and then it actually exits the loop. So if at the end it couldn't find anything, then we say, okay, the key was not found, basically. So let's run this. So you see here, it found that 4, 5 is a tuple. It was common between these two. And then, but here the break is actually only from the first for loop. So once it finds it, it actually exists. But then since we are iterating through the test, for the second item, it again looks for the item, and then it says, okay, 3.14 was not found. Right? So is that clear why what this break does here? So basically, so let's say the first element was 4, 5. It looks for the second list, which is items. It starts looking until it finds, and then it exits the second for loop. But then continues with the first for loop. Okay? And also, yeah. What's the question? Oh, the light. Okay. Okay. Is this better? Okay. So I think we talked about range briefly, but so we can actually use this object range mostly for the for loops. If we want to iterate over some numbers between some range that we want. So it's actually an iterable 2. So in this class, you will get used to this word iterable a lot. So range is an iterable that generates items on demand. So if we want to display the results, we actually need to wrap it with list. So for example, if I just say, let's say range 3, it actually returns this range as an object. But if you want to see everything at once, if you want to see what this range is really generating, you can say, for example, here I have 3 different examples for range. So this one, when you just say range 5, it will generate values from 0 up to 5. 5 is not included. So the second one generates values from 2 to 5, and again, 5 is not included. And also this one generates actually 0 to 10 with a step of 2. But if you want to see what it is really generating, you can actually need to wrap them up with the list to see the real results. So you see, so it is like, so this is actually printed what we just expected here. Okay? Yeah, so you will need to use this range a lot for your for loops, especially if you know where your values start and end, if there is a constant size, constant step size. So for example, if you want to see each value of range, you can just write it with the for loop and see what it really has. So here you see, so 0, 1, 2 when you say range 3 basically. Okay, so range is actually a very useful tool in Python that you should be familiar with for sure. Okay, so let's get a little bit, let's have a deeper look in the iterations. So far we mentioned that the for loop can work on any sequence type like a list or tuple or string, but it's actually even more generic than this. It works on any iterable object. So what do I really mean by that? So an object is iterable if it is stored, if it's a stored sequence or an object that produces a result at a time. So for example, we didn't actually touch that yet, but if you are reading a file, it generates output for each line when you read through. So the full iteration protocol, it actually has 2 objects that we use in the iteration tools. So the first one is the iterable object you request for iteration. And the second one is the iterator object that returns the iterable, that produces values every time when we call this next. Okay, I know it is not very clear what I write here, but you'll see it by demonstration in a minute. So let's say we have this list, 1, 2, 3, okay? Very simple list. And then we actually wrap it up with this iter function. It actually generates an iterator object. So L is an iterator, which already has this sequence of values. And when we wrap it up with iter, which now we assign it a name as I, then it generates iterator object from an iterable. Okay? And now once we generate this iterator object, so every time when we call this next, underscore, underscore, next, underscore, it actually calls the iterators next to get the next item. So in this case, what do you expect? 1, right? And then when I call it second time, do you expect to get 1 or 2? 2, right? That makes more sense. And then, of course, the third time is going to be 3. But now we actually exhausted all the values. Then what do you expect the next one to yield? So it actually has this stop iteration error raised, because that indicates that, okay, you exhausted this object and In order to go back to the first item here, you actually need to redefine this again. When you say iter L, then it resets your iterator object and starts from the beginning again. Is this clear? Okay, but this initial step, when we wrap it up with the iter function, may not be required for some object types, such as files. And also you'll see more object types that it doesn't require this iter wrapper. But lists and many other built-in objects are not their own iterators, because the reason is because we want to support multiple open iterations. So imagine you have a list that you think you might iterate over it multiple times, so you don't want it to be an iterator object, because once you exhaust all the values, next time you call, you have to wrap it up with iter again. So that's why it's better not to have their own iterator objects for some iterables. But for example, if you are reading a file, it makes more sense to go through your file only once. So it actually doesn't hold so much memory. Once you exhaust it, once you go through your file, you are done. You don't want to keep it in the memory. Okay. So how are all these things related to the for loop? What does really for loop do under the hood? So these Python iteration tools like for, they actually call this iter wrapper automatically. But we can also do it manually by ourselves, because we know what is going on under the hood. So we can implement it if we need to. So again, let's look at this list L. So here, it actually, so when we do this for loop, it generates this iter of L, and then every time it goes through the items, it actually runs that underscore underscore next underscore underscore function. Okay, but you don't see it because it is automatic. And here, of course, what I'm doing is just for each value, just take the square. That's what I'm doing, very simple task. But that's not the point here. The point is here to show you that for loop, in order to do the iteration with for loop or other loops, you don't really need to do this kind of iter wrapper. But let's say you want to see how you can have your own iteration without using the for loop or without having this automatic iteration. So in that case, you can first define this iterator I by just wrapping your list L with this function iter. And then we can actually have this while loop. When it is true, we can keep calling the next item here, right? So every time for x, call the next item. So x is actually the next item of your iterator I. And then if it doesn't work, because if you remember this try statement, it actually tries to run it. If it doesn't work, it actually continues. So it's more like error handling. So this does exactly the same thing as the for loop over here. But this was a manual iteration because we had to do this. So you probably don't need this in most of the time, but there might be a time when you work in a bigger program that you may need to run your own iterators. That depends on the file or the objects you are working on. So in that case, it's actually good to know these kind of statements. Okay? Okay, so what am I doing here? Okay, so you can do the same thing with range. Okay, so you can assign range to R, and then so these are iterables too, but they are not an iterator as we just talked. And then we can first it generates 0, and then second it generates 1, and so on. It generates values up to 5, not including 5. But if you want to see everything at once, you just do list. Okay? So this is the idea of iteration. And also, so Python has this nice tool which is also called enumerate. So sometimes, you realize with all these lists or sequences, the indices are important, right? So you like to, it's good to know the index and the item of the list that you are interested in. So in that case, you don't really need to run another script for that. So this enumerate function actually just generates the item of your iterable and also the index, corresponding index. What do I mean by that? For example, if you do this for loop and enumerate over spam, it actually, so it says that the index 0 is S, index 1 is P, index 2 is A, index 3 is M. So this is something I find very useful, and I actually use it quite a lot. And it's also good to know that enumerate itself is an iterable too. And it's also an iterator too. So basically, you don't need to wrap it up with iter. If you just want to check that, if you want to see if you need to wrap it up with iter or not, you can actually check the equivalence. So is iter E equal to E? So it says yes, it's true. That means you don't really need this wrapper. So so another meaning of this is that once you exhaust all your items, once you go through the output of this enumerate, you are done. So in order to reset your iterable, you need to define it again. Is that clear? Okay, so in this case, for example, what do you think the E.next will be? Okay, so let me run this. Okay, anyway, yes, so it will be 0, 1, right? Sorry, 0s, right? And then second one will be 1p, and so on. And then the last one, of course, you are gonna get stop iteration error. Okay, so I want to illustrate something else here. So let's say for E in E, print E. Okay, so what do you think the print is going to be? The output of this is going to be? Remember, we just defined this, and I ran it 2 times, and now I'm here. Any ideas? Okay, again, so I have this enumerate spam. I assign it to E. And then I ran this next call twice. So I exhausted the first 2 items. So now when I go through the for loop, it should continue with the 3rd item, right? So, and then it should, yeah. See? So it remembers where it was left off. And then next time when I try to run E __ next, now it's an error because I already went through all the items in this iterable. Okay? All right, so Python has these other tools called map, zip, or filter. So we can also look what they are really generating. Is that just an iterator, or does it generate And so is that just an iterable, or does it generate an iterator? So in that case, so do you know what this does? What the values of m is in this case? So what does it look like? Yes. So basically, for map function, you input the function as the first input, and then you give the second input as which is a sequence. So map applies this function to each of the values here. So it looks like absolute value of -1, absolute value of 0, absolute value of 1. So if you look at m, okay, so this is actually, of course, so here you don't see the results. If you want to see the results, what do you do? Actually, I'm not, yeah, okay, it works. So if you really want to see the results at once, you just wrap it up with list. So does map require this iter wrapper? So we can check that. So it doesn't. So basically, it is its own iterator. Okay, so which means once you go through all the values, you are done. You in order to go back to the first value, you need to reset it. And okay, so actually, do you think this will work or not? m.next. Who says it will work? Who says no? Why do you think it doesn't?
I answered it.
Oh, you answered. Why do you think it doesn't? But I mean, do you have an explanation?
No,
It doesn't work because I just ran this. So when I applied this list function to m, it ran through all the values, and then next time I called it, it gave me an error. So what do I do here? I need to reset it. So basically, I need to redefine it.
So is the only way to reset it by redefining, like you just did? Is that the only way to reset it?
If it was a list or other iterable, you could do iter too, you know. But for this, yes, you need to redefine it. And now it will work, right? Because I reset it. And the second is going to be 0. Third is going to be this.
Do we have some function to
Reset?
Yeah, reset that.
Not as far as I know of, but you can write it. You can write your own reset function.
So we just run that again, run the function of m again.
Yeah. Okay, so of course this is not going to print, right? Because we just went through all the values here. So the output of this is actually none. That's why we don't see anything. And then again, we make a new iterable and iterator for this case, and then later it works. Okay, and this actually we already did this. This is to see all the values at once. Just wrap it with list. If you need something that you think you will need all the time, you can just make m equal to this. You know, if you don't want to reset all the time, you can say make it a list. Give me all the values at once. Does it make sense? Okay. Okay, so that was about map. And there is also, I think we mentioned this zip too before, but we never discussed as an iterable iterator, of course. So it is so similar to map. It also returns an iterable with an iterator. That works the same way. So do you remember what this zip does? Okay, so we'll see. So, okay, now when I said just z, I can't see all the values because it's an iterator now. And then if I want to see everything, I say list. So basically what zip does is, so it looks for your two inputs, which are both sequences, and then it pairs the first item of the first sequence with the first item of the second sequence, and then second item of the first sequence with the second item of the second sequence, and so on. Okay? So here you see that the output, when we type it as Z, you see that it's like 1A is the first output, 2B is the second output, 3B is the last. Okay? And then, do you think this is going to output anything? No, right? Because I just ran it by typing list. So now it is like, no, sorry, you went over it once. And then I define it again. And with a for loop, I can actually, so I can define this pair too. And then it gives me each of these pairs of the output of this zip. Okay, and then of course, so this was with the for loop, and you can also do the manual iteration where this iter wrapper is not necessary. So I define it again, and then I look for next value, and all that. Okay, so is zip clear too? So it actually pairs up all the items in your sequences, which can be useful sometimes. All right, so the filter, it is, so what it does is it actually applies the function and then returns only if the value is true. So for example, so here it applies bool function, and then so applies it to spam or to empty string and to this, and then if the value is true, that returns it. So it's basically what the name sounds like. It's filter. It filters out your results based on the function you give as the first input. Okay? So what do you think the output will be? Yeah, but we don't know it yet because it generated an iterator, right? So if you really want to see it, so this is what you said, right? So this is actually similar to what we can do with the list comprehension, which so you go through each items, and then if it is true, then you return it. If it is not, you don't need to. So same thing, right? So same kind of filtering tool. Okay, so what do you think the output of this will be? Right, same, yeah. So basically, typing bool x is same as x because it will return false if it is empty, and empty strings are going to return false, of course. Okay.
How we do the filter the false? We set to true.
Oh, so if you want not true,
Yeah.
then you can say if not.
So in the original form, the filter method, how to do that?
Oh, I see. Okay, that's a good one. Let's try. Does it work? No, it didn't work. No, it didn't work again. Yeah, I think you need to write another function. Let's say, I mean, we didn't talk about functions, but you can define a function that says not bool, okay, x, whatever. And then you can say return false. So you can actually type something like if x return false as return true. Okay. And here, if I say it worked. Was that clear? So I just wrote my own not bool function and put it here. Okay, so we'll talk about the functions soon. So this was a nice introduction maybe for the function syntax. So is everything clear up to here? Do you have any questions? No? Okay. All right, so maybe before we move to functions, we can have a quiz now again to remind you what we learned last week. So prepare your pens, please. And you will have very short time again, 4 minutes. And if I see you cheating, you'll get 0. And you'll have more trouble, okay? So please don't do that again. Okay? So I'm really serious. It's really not worth it. Okay? Okay, as usual, nobody opens it until I say so. Okay? You're too cool. Don't open it. Nobody opens it and computer's closed. Nobody starts. Set my timer. Sorry. All right, okay, now you can start. Don't forget to write your name, please. So turn it over, please. Everybody. No typing. If I see you typing, you'll get 0 too. Okay? And then start collecting from that side. Okay. Start collecting. Can you guys stand?
如果是 int 型，不存在一个低级投方法，一定是一个 string 型的方法。那怎么判断它是一个低级投方法？如果是 int，它就不需要低级投方法，所有的 int 型一定是像string 代这个方法，它一定是string才会。
Okay, how was it? Was it easy? No? So, do you want me to go over it? Yeah. Oh, wait. Okay, so the order might look different than yours. I randomized it, so you guys had different versions. Okay, so what do you think for this one? A? Is it clear? Okay, so actually I want to draw this. Is there? Okay, maybe not. Is there? Good to know. Anyway, so here. Oh. I don't think they can see it, but anyway. Thanks. Okay, so basically here, so A and B both refer to the same object, right? And then we change the value of that object inside. So we are changing the value of what they are both pointing to. So that's why this will change the value of A. So for this one, so A points to this object spam, and then we make B to point to the same object. And then by assigning this, we are just changing what B is pointing to, right? So instead of pointing spam, B is now pointing orange. So here, so how is this different than A? Exactly. So once we use this, it actually works on the copy of it. So once you change the value of the original list, it actually doesn't change the other list because it's operating on the copy of it. But remember, this was a shallow copy. So if there was another, if this was a list of lists, then that could have affected A too. We talked about that deep copy, shallow copy. But once, if you don't have list of lists, then they are both the same. And this one, can you actually do this operation, right? So this is, strings are immutable, so you cannot actually assign another value to them. Okay? All right, so what about this one? This one? Right. So basically, so we say if this is true, assign T. So if spam is a non-empty list, it returns true. That's why the output one is going to be T. But here, if empty, so empty is false, so it assigns F. So it is TF. Right? Okay. All right. So what is this one? C, right? Right. So basically, while we still have X, then reduce the value by 1. And then if it is odd number, continue. Otherwise, print this statement. Okay, so what is this one? So anybody who says something else for this? Okay, I realize you guys don't see it well, maybe. D? B, right? Right. So basically, so here the reply is a string, and while everything is true, so this condition is not satisfied, and this condition is not satisfied because it is a digit, and then it converts the string to integer by running this, and since the value is less than 20, it prints log. Do you have a question?
That doesn't assign it as a string. Because like you have the double quotes around that.
Yes, so that means it's a string. Yeah.
So what you do is
It works on the strings, basically.
It's checking if the value in the string is a digit or a number, a
Yeah.
alphabetical character.
Yeah.
The output should be no without quotation marks.
Yeah, if you
You put the quotation marks out.
Oh!
There should be no answer. There should be no answer.
Okay, yes, good point. Yeah, okay, that's my bad. So what did you pick then?
I did wrong. I didn't pick no.
Oh, okay. Okay, but did anybody not do this right because I put quotations here? Okay, let's try to be honest here.
Actually, at first time, I see the quotation and I choose another answer.
Why? What was your logic? Other answer.
I don't know.
You know, there is always one true here. Okay. Anyway, I guess it wasn't a big issue, but thanks for catching though. Okay, so that's it. I hope it was fun for you. Okay, now let's continue with the function basics. So once you are able to write functions and for loops, you are pretty much good to go. You know, so you can start writing Python programs. Okay, so functions are the most basic program structure that Python provides. So why do we need? Okay, guys, do you want to discuss something else? Looks like, okay. So let's continue. All right. So functions actually provide maximizing the code reuse. So what does that mean? If you have some operation that you think you may need to use a couple of times, so instead of writing it over and over again, you can just define one function and call it every time you need that operation, right? So they actually serve two primary development rules that you should be familiar with. So again, maximizing the code reuse and minimizing redundancy. So usually it's not considered good to have really long programs. So we like to have things as short as possible. You know, if you see 1,000 line of code, the coder is probably not a good coder. Okay, so it should be like maybe at most 100. Shouldn't go more than that. And then it's also good for the decomposing your program. So it's actually in the book it was talking about making a pizza robot. If you are making a pizza robot, first so you actually distinguish the tasks, right? So first you have like one subtask where actually you prepare dough, and there are other tasks that you put the ingredients, whatever. And this actually, so it wasn't mentioned here, but having these decomposing the tasks or having these subtasks usually makes it easier to run your tests too. So I don't know if you noticed how I wrote the tests in the assignments. If you saw it, actually each test is independent from each other. And I try to, so the reason is that I just want to check one thing at a time. So it helps me, also since I'm assigning you the assignment, so each task of the assignment is like a different function, that helps me make the test easier. So you should always keep that in mind. So once you have simple function, testing will always be easier. Because when something breaks, and if you have a spaghetti code, it's really hard to debug and run the test and all that. Okay? All right. So how do we define functions in Python? So this is the general look. So you define the name of the function, and you have all these arguments, inputs, and then you type your statements, basically. So this is pretty much how all functions look like. But you can also use the return statement, which is optional. You know, in some cases you may not want to return a value, but in many cases you actually return a value. So this is how you output your value in Python inside a function. Okay? And this return statement can actually show up anywhere in the function. So when it is reached, then it ends the function call and sends the result back to the caller, basically. So this return statement doesn't have to be at the end of your function. It can be anywhere. Okay? I mean, you might think, why should it be at the middle? I mean, then why are we writing the rest? Well, there might be some cases where you want to return the value. Let's say if the string is empty, but you want to continue processing if it is not. You know, so that in those kinds of situations, that using return at other places in your function might be handy. Okay, and also, so the function definition happens at runtime, so there is nothing really special about the function name. So what is important is the object that it refers to, as like variable names too, if you remember, right? So variable names are not that special, but what they are pointing to, the objects that they are pointing to, are more important. So for example, you can, if you have some function, you can assign it to another name and just call it exactly the same way that you call the original function. Okay, so let's have a few examples. Let's say you just want to multiply two values. You know, so let's call this function times, and then it takes two inputs, x and y, and then it returns the multiplication of these two variables. So this is the definition of the function. So remember, you have this def here, and you have this colon here, and we have this return here. And then the way you call it, you say times. So when I say times 2, 4, it actually assigns 2 to x and 4 to y, and multiplies these two and returns 8, basically. Okay? And then here we didn't assign anything to the output, but let's say I assign output to this variable x. In that case, so it again assigns 3.14 to the value x here, and 4 to the value y here, and then multiplies them, and x is the result you have. Okay? And then, so what if I do this? Do you think it will break or it will still run? Why do you think it will break? So remember, so the function we have is this, times xy. So it runs, for the first variable and second variable, it runs x times y. So here, that will run ni times 4. So it outputs 999, right? Exactly. So that actually to remind you that functions are actually typeless, unless you have some operation that depends on a type that's not defined for other variables. Okay, so let's do something a bit more useful. So let's say we define this function, and that takes 2 arguments, sequence 1 and sequence 2. And then I start with some empty list here, and I look for each variable at sequence 1. And then I have this if condition here. So if that item is in sequence 2, I say append that to my result list, and finally return me the result. So what do you, so for example, if I run this function for this, what do you think the result will be? So do you understand what this is really doing here? Right. Not similar, same character. Exactly the same character. Right. So then what is the output of this? SAM, exactly. Right? So what it is doing is, so when we say func S1, S2, so it assigns spam, which is S1, to sequence 1, and scam, which is S2, to sequence 2. And then it starts treating each of these. So it looks at the first X is going to be S, and then it checks if S is in sequence, append it to my result. And then it goes to the second item, which is P. If P is in second sequence, then it will add it. But P is not in second sequence, so it will move to the next one, which is A. And A is also in the second sequence, so adds it, and so on. And also realize this indentation in Python, which is very, very important. So nothing will work if you don't have this right indentation. Okay? So notice that after defining the definition, I have this indentation, and then I start writing my block. And then for loop, I start another indentation. I have another indentation, and same for if. And it is actually a nice thing. So it gives me this nice structure of the code, which gives me a better idea, right? So I can immediately tell that there are actually, there's a for loop here, there's an if statement here, all that. But if it was another language, you wouldn't need to put any of these indentation, and things will still work, but it wouldn't look good. It will be really hard to read, okay? So even if it is not really necessary, people just, people still want to use indentation just to make it more readable. All right, so let's run this one. And then, so, okay, it returns SAM. So is this clear, everyone? It's definition of a function, and then assigning arguments, inputs, return. Any questions? Okay. Okay, so all right, so let's do a little bit an exercise here. So can we do exactly the same thing with using comprehension? So can anyone guide me with this? Any ideas? Okay, I'll start with making this list. Okay, so I return X for X in sequence 1, right? So I call, sorry, S1 if, tell me,
S2 equals.
Hmm? What did you say?
I was gonna say, like, instead of saying x for x in S1, if x in S2, like, I was gonna choose a different variable, like dummy variable, like if y in S2 equals x. I'm not sure though.
I mean, you can walk me through it. You can debug.
Okay.
Do you wanna type it?
I
No.
mean, I was gonna just, I don't know how to type it. I was gonna replace the second x, like if x, so like if the dummy, like a different variable, if y in S2 equals x,
If- Oh, okay.
like equals, like 2 equals is equivalent to x.
But for that, you are actually doing two for loops.
Yeah, that's not.
Yeah, it's usually for list comprehension you don't want to have nested loops. So it's better this way. So it returns the same thing basically. You know, just to remind you list comprehension and what we did here, and also to show that what we defined as a function here is really simple thing that you can easily write it with a list comprehension too. Okay, so for this one, what do you think it will print as an output? Remember our function?
Just one.
Right, exactly. So it just looks for the common variables. Okay? Okay, so here there is one thing that I want to catch your attention about. So inside this function, I have this variable res, the result, and also I have this x. Do you think if I type these values somewhere here, what do you think I will get? Nothing? You mean none or error? Error, right?
Error.
Exactly, because once it exists this function, then actually it will erase all these names. So they're only live inside this function. Okay. So this was to prepare you for the next topic, which is called scopes. So scopes are the places where variables are defined and looked up. So they actually had to prevent name clashes across your program's code. So when you actually use a name in a program, Python creates and changes and looks up the name in what's known as a namespace. So namespace is the place where names live, okay? And functions add extra namespace, like this result or x, namespace layer to your programs to minimize the potential for collisions among variables of the same name. So let's say I had another x in my program, but I still wanted to use another x in my function, which is completely a different thing. So I want my function to use that local variable, not to deal with something else. So that helps you to avoid the collision. And so the names assigned inside a def or a function can only be seen by the code within that function, as we just said. And you cannot even refer to such names outside of the function, as we just tried. So yeah, again, so the names assigned inside the definition do not clash with the variables outside of it, even if the names are used somewhere else. Okay? So basically, the variables may be assigned in 3 different places corresponding to their 3 different scopes. So if a variable is assigned inside a function, which is by this def, so it's local to that function. Okay? So we call that local. If a variable is assigned in an enclosing def, so let's say you define a function inside a function, and then that variable is non-local to the nested functions, which is not very common though, so don't get too confused about this. But if a variable is assigned outside of all definitions, it's called global to the entire file, which makes sense. So you can think more like, okay, is this variable global or local? That's what you should ask yourself. Okay? All right, so for example, in this case, we have this x, which is 99, which is a global variable. Okay? And then I define a function which also has x, but here this x is local. Okay? And now what do you think x will be when I run this? 99, right? Makes sense. Exactly. So basically, we call this LEGB rule, which so the rule that Python looks up for the variable that you use. So basically, it first looks at the local variables when you use it, and if it doesn't find it, it looks for the enclosing function locals, which we call as non-local, and then if it couldn't find it, then it looks for the global variables, and finally, if it is not in global, it looks for the built-in variables that Python has. Maybe you have something that's defined somewhere else. And finally, then if it doesn't find any of these, then it throws an error. So basically, it's called local L, enclosing function locals E, so global G, and built-in B, so LEGB. Okay? All right, so let's look at this one. So we have x as 99, which is a global variable. And then we define a function, y, and we return z. So if I call this function with the function 1, what do you think the result will be? Do you think it will give an error or it will work? Who says error? If it is not error, then what do you think the value will be of this? 100, right? But this x, someone said no? Okay. So this x was not defined in the function. So it says, okay, I can't find it in the local scope, so let me go up. Oh, I found it in the global scope, so I'll use it. And you define y as 1 already. So 99.1, 100. Okay? All right, so what about the built-ins? So this is actually very strange. I didn't know this before preparing this course, this class. So you need to, the built-ins are not built-in themselves. So in order to find the built-in variables, you need to import it and then look at the values. Okay? So remember, if it doesn't find your variable in the in local or non-local or global, then the next part it's going to look is the built-in functions. So built-in scope, sorry. So in this case, you can look at what are in the built-ins. You see all these values here. Of course, you don't need to memorize it, just to give you an idea. Okay? Actually, I want to current output clear. Okay. So, for example, so you know zip, we just talked about it, right? That actually pairs up your sequences. So you can actually check if built-ins also has zip by just importing it, and you see it's actually under the inside the built-ins. So if you define something like if you try to use zip somewhere, you don't need to define it because it's a built-in function. Okay. All right. So let's look at this. So x is global, 88, and okay. So we just saw this, right? So the output of this is gonna be what? 88, right? Okay. So what about this one? I say x is 88, global x, and x is 99. And now function. Here, actually, I'm telling my function to use the global x. So now it changed the value of the global x to 99. Okay? Or you can do something like this. So everything is global here. X is 5, y is 1, z is 2. And then here I say global x, y plus z. So for y plus z, it gets the values from here. And then it assigns 3, right? 3 to x. But since I use the global x, it will change the value of x. Right? So it's going to be 3, basically. So let's say you have two functions. So you have this global variable x anyway, and then you have two functions, function 1, function 2. So one of them assigns 88 to x, and other one assigns 77 to x. So basically the value of x here, as you can see, depends on which function was called last. But this is really not a good practice, right? You don't want to mess up with your global variables that much. So it is usually, so when you're a programmer, you should always keep in mind not to use too many global variables. It's always a bad practice, okay? So in this case, just define it. So yeah, so this is actually, yeah. So functions are dependent on the global variable, and this is the problem with globals. So they generally make the code more difficult to understand and reuse than code consisting of self-contained functions that rely on locals. Okay, so functions should be self-contained, and they should generally have one responsibility. You should keep that in mind. Don't try to add too many things inside one function, okay? So yeah, this is actually another bad practice. So yes, you can define a function inside a function, and here, so we have this x. So but this is just to show you the non-local. So we talked about locals and globals. So this is for the non-local. So basically, x is global, and this x 88 is non-local to f2. So basically, when I say print x, since it couldn't find x in local in f2, it looks up and then it finds this x instead of using the global x. Okay. So here, okay. So what do you think the output of this going to be? So I run F1, so F1 will run this, and it defines F2 here. So it runs F2, and F2 runs this, so basically it's going to be 88, right? But, so it took a couple of seconds for me to understand what it was really doing, so it's, really not a good thing to have all these nested function definitions and so many different global, local, non-local variables. Okay, so anyway, so that was all about the scopes.
If I write global x in F2, what will happen?
Good question. Yes, so what do you think it should happen? Global x. Because here the global variable is 99. So I'm telling it not to use the locals or non-local, local, they're both the same here. I'm telling it to use the global. Okay? So, but let's erase it. Okay? Yeah, good observation. Okay, so let's talk about the arguments. So, just for basics, when we define a function fa, so a is assigned to the past object and it changes the local variable only. So basically when I say b88, then fb is going to be what? So what is the output of this going to be? You think? It's either 88 or 99, right? There's not much options here. $88? Who says 88? Why? Okay, so it only changes the value inside, but it doesn't really change B itself. Remember, so it's immutable anyway. So it's going to be 88, okay? Because, I mean, if you assign, if I had a return statement here, if I said return A and then assign B to f of B, then it could be 99, right? But in this case, it didn't change anything. Okay, so in this example, the variable A is assigned to the object 88 at the moment when the function is called with f of B, but A lives only within the called function. So changing A inside the function has no effect on the place where the function is called. So it simply resets the local variable A to completely a different object, basically. Okay, but when arguments are passed to mutable objects like lists and dictionaries, you need to be a little bit more careful. Because we need to be aware of the in-place changes to such objects, which may live even after the function exists. Okay? So for example, in this case, I define this function, changer, okay, that takes two values, A and B. So I assign A to 2 and the first element of B to spam. And then I have these two variables, X, which is 1, L, which is list. So when I do changer XL, what do you think the output will be? So what X will be? Yes. L, what do you think L will be? Spam 2, right? Because L is mutable, and then we just change the value that it's referring to here by assigning spam to the first item. Okay, so let's see. We are right? Yes. Okay, so what about this? What do you think? So what happens to the value of L? Right, so when I run this, so let me run this. Oh, I hope it doesn't output. Yeah, it shouldn't output anything. Okay, so I run this. So for L, what do you think L will be? Will that be spam 2? Run this. Should be 1, 2. Why? Exactly. Because here I sent a copy of L, not L itself. So that will be 1, 2. Yes?
Can you pass a reference for a variable? So when you pass, like, say, one variable to the function, and you make some change, it applies it to the actual variable?
I mean, so it depends if the variable itself, the object the variable is pointing to or referring to is immutable or not. So in this case, for example, when we send the L, so we actually use the same object that L is referring to. That's why it changed the value of original L. But here, when you send a copy of it, it doesn't. So it creates a copy, so it operates on the copy of it, but it doesn't really change the value, the original. Okay. All right. So a little bit about return statement. So here, so let's take x and y, and then we just return the values of x and y, basically. This looks very boring. Why should I do this? Oh, okay, yes, that makes sense. Okay, so, so I just assign 2 to x and 3, 4 list to the y, and then I return those. Okay, so here I define new variables, which is x and 1, x is 1, L is a list 1, 2, okay? And then I want to call this function multiple, and then I want to return x new and L new as an output of this function. Remember, notice that it actually gets the values in order. So the x goes to what I defined here, y goes to what I defined here as L new. Okay, so when I run this, what do you think x new and L new will be? There are only 2 options, right? Who said 2, 1, 2? Did you say 2, 3? It's not one of the options. Okay, so let's see. So x and L, right? So x is 2. So x is 1, L is 1, 2, and the output are going to be xy. So basically, of course, the new ones that you return are going to be, because I assigned it, I said return me these values. So of course, x new and L new are going to be 2 and 3, 4. Okay? But what happens to the original values? No change? Right. Yes. Exactly. Because I'm not really operating on what they are really referring to. Okay, so I'm just saying, so they actually only, so they are only live inside this, and then once you are done, it's over. So it didn't change it. So this is something you should always keep in mind in Python. We saw this many times. Like sometimes there is an in-place change, sometimes there is not. And there is, of course, a logic behind it. So always be aware, especially if you are working with mutable objects, make sure that you are not unintentionally changing the values of the objects. Okay? All right. So far, I just assume that the arguments match by position. So whatever the first argument, so whatever I use as an input, the first one, it goes to the first argument. Second one goes to the second argument. And third one goes to the third argument, right? So when I define a function like this, if ABC, print ABC, it will print actually 1, 2, 3. Because it takes 1 is A, 2 is B, 3 is C. But you don't need to do it. There are other ways to have the arguments in a function. For example, I can tell, so this is to call the function. if I don't want to use the position, I can say C is 3, B is 2, A is 1. So it understands that it should assign this 3 to C, this 2 to B, and this 1 to A. It's pretty nice, isn't it? And you can, they don't need to be in order. And of course, this also returns 1, 2, 3, because we are printing ABC. Okay? Is this clear? Right? So this is, okay, so this is another example. So here, if you don't use a keyword, it actually takes whatever is the first. So in our case, 1, since it is A, it assumes, okay, so you are giving me A. I know it by position. But then I say C is 3, B is 2. So here it knows that I'm using keyword now, not positions. So A gets 1 by position, and B and C are passed by name. And now we run this. The result is still 1, 2, 3. Okay? So this is another way to call your functions. This is actually nice because it makes your code more self-documenting. You know what you are really inputting, at least. Okay? All right, so what if you want to use some default values for your variables? Let's say I want to say that B is always 2, C is always 3, unless I assign it, okay? And A doesn't have a default value. So this is how I define the function with the default values. And then when I call the function, if I just input 1, then it will replace A's value with 1, but it will use the default values for B and C, which is pretty nice. If there are variables that you want to use defaults most of the time, you can just use this, and then you can change it only if you need to. So this again prints 1, 2, 3, which makes sense, right? Or so here it got A's value by position, but you can also do it by keyword too. So I say, okay, pass 1 to A, so it's still 1, 2, 3. Okay? But what if I run 1, 4? What do you think the result will be? F1, 4. So this is the definition of F. 1, 4, 3, right? So anybody cannot see that? So again, so this is the definition, and this is how I'm calling the function, 1, 4. So it takes 1 as A, and 4 for B, because I'm telling my function not to use the default value 2. I say replace it with 4, but I'm using the default value for C. Okay? So that's why it's going to be 1, 4, 3. So let's run it. 1, 4, 3. Okay? And of course, you can assign values to all the variables. So when I say 1, 4, 5, it just ignores all the default for B and C. So it will print what? 1, 4, 5. Right. Okay? All right. So we can also combine keywords with defaults. So let's say you have a function which takes variables as spam, eggs, toast, and ham. Okay, and toast and ham have default values of 0. So when I run this function 1, 2, it's going to print what? Yes, 1, 2, 0, 0. So assign 1 to spam, assign 2 to eggs, and use the default for the rest. Oh, why? Because I didn't run this one. Okay, so let's try again. Okay, 1, 2, 0, 0, right? Okay, so what about this one? 1, 0, 0, 1? Yeah, so for 1, it assigns to spam, right? Spam is 1. X is 0. Toast is already 0, use the default. And for 1, for ham, use 1. So it's 1, 0, 0, 1. Okay? So I used both, so I used default for the toast, but I used the keywords for ham and eggs, and I used the position for the spam, basically. And this one, spam 1, x 0. What does it output? Right, 1, 0, 0, 0. Okay, so what about this one? Toast 1, x 2, spam 3. Yeah, so spam is 3, x is 2, toast is 1, and ham is 0. So 3, 2, 1, 0, right? Or like what we did at the beginning, you can just do everything by position. Just run function 1, 2, 3, 4, which will output 1, 2, 3, 4, right? So it basically just uses 1 for spam, 2 for eggs, 3 for toast, and 4 for ham. Okay. 1, 2, 3, 4. All right. So there is also another way of passing the arguments. So this is you can actually use this star or double star. Basically, you can just say star arguments and then arguments. So you don't need to give the number of arguments. So it takes whatever you give as an input. So let's see what it does. So here I'm defining this function f that prints all the arguments. So when I say f with an empty input, it is going to do what? It's going to print nothing, right? And then if I say f1, it actually prints 1. But notice the output is actually a tuple here. And then if I say 1, 2, 3, 4, the output. So basically, if you don't know how many arguments you will need, you can run these star arguments. So when this function is called, Python collects all the positional arguments into a new tuple and assigns the variable args to that tuple, basically. And double star feature is similar, but it only works for keyword arguments. So it collects your arguments into a new dictionary. So let's define this function that takes this star arguments and print everything. So of course this is going to be empty. It returns nothing. And now when I say A1, B2, it's going to print the dictionary. A is 1, B is 2. This is actually, especially these 2 star arguments, is actually a pretty useful tool. So you don't really need to define all the arguments you need to pass to your function. It finds it from whatever you input to your function. And it creates a dictionary for your arguments. And also we can combine this. We can combine, I can just create one variable A, and then another variable that actually creates a tuple, and another variable that creates a dictionary. And then I can say print all these values. So in this case, what do you think it's going to print? Right. Yes. So by the way, when I say p args, that means actually positional arguments. Key args, I try to say key arguments. So it's basically that's what gives you dictionary. So in this case, when I type 1, 2, 3, so it assigns 1 to A, and the second positional arguments are going to be 2, 3, and for the keyword arguments are going to be dictionary with key X and value 1, key Y and value 2. So this is what it will output. Okay, so you can combine all this as an input to your function. Okay, so this was, we have been just printing arguments, so let's do something a little bit more useful. So I'm gonna define these two functions. So one is intersect. Let's see what it is doing. So it takes these position-based arguments, and then it creates an empty list, which is for my result. And then for the arguments, let's say the first item of the first argument, and then if that item is in my list res, then continue. And then for other in the rest of the arguments, and if X is not in other, then take a break. Otherwise, append that X to your result. So basically, what is it doing here? So for all other arguments, looks at an item in each one, and if it doesn't exist, break out of the loop. Otherwise, add it to the result. I mean, so it actually finds the intersect between your list, which I will demonstrate soon. And union does the union, as you can tell. So it goes through all the arguments, and for each argument, so let's say your argument has sequences, and for each sequence you go through each item, and if it is not in this result list, then append it, basically. Okay, so let's demonstrate what these things really do. Let's run this. So here I'm creating two strings, S1, S2, S3. So spam, scam, slam. Okay. So if you remember, I can do the assignment this way, So when I do this, it actually assigns spam to S1, scam to S2, and slam to S3. And then if I run intersect S1, S2, which will look for, so my arguments are going to be spam and scam. Okay, so let's see what it is doing. So argument 0 is what? Spam. So X is S. If X is in result, continue. But if it is not, and then for other here, so now I'm looking at the second argument, which was scam. So the first item of that second sequence is also S. So if X not in other, which was, remember, so X was S. So if it is not there, break. Otherwise, append it to my result. Okay, can you see this? So basically, replace this argument 0 with spam, and this one with scam, and then it looks equivalence of X and other. This is actually the logic you were proposing. So using 2 for loops, and then go through each item until you find the common variable. And so same for union. It goes through everything and then keep appending all the values if they are not here. So for this, when I say intersect S1, S2, it's going to look for spam and scam and look at the intersection of those, SAM, which is going to be SAM. And union is going to be, of course, union of this. But this is really not the interesting part. This is not, I mean, we didn't necessarily need this to use these star arguments. So what is more interesting is you can actually input 3 of these, and it will find the intersection of those 3. Because here, it goes through for all other arguments. So looks at the first arguments, which was spam, and then second argument scam, and then does another loop for the slam, basically.
Is it comparing spam with the other two? Does it compare the first argument with the other 2 arguments? Or does the second and the third one get compared as well?
So, yeah, so it assigns the first one first,
Yeah.
and then as long as you have more, it keeps running more
so
for
it's
loops.
comparing the first to the second and then the third one, right?
Yes, exactly. I mean, if you are confused about what it is really doing, you can actually print these things. You can add some print statements in wherever you want in the code to actually really understand what it is really doing. Okay. But the idea here is actually to say that, okay, so if you don't know how many arguments your function will take, it's good to use this star feature. And if you know that your arguments might be a dictionary, but you don't know how many you will have, then it's good to use double star args. Okay, so if we run this, okay, so this is, if you see, this is actually mixed type. So the first argument will be 1, 2, 3 list, and the second will be a tuple, but it still works because we don't have this type issues in our function here. All we are doing is we are just iterating through. Okay. All right, so let's talk a little bit about more advanced function topics, which is like recursive functions. So by the name, recursive functions are actually the functions that call themselves. So for example, in this case, I define a function f, and if not L, I say return 0. Otherwise, take L0, the first element, and then add it to the result of the function which is operated on the rest of the list. Okay? So can you tell what it is doing? What is, if I run this, what is the output of this will be? What did you say? Right. So it calculates the sum, right? So basically, what is it? So for example, for 1, 2, 3, L is not empty. So I go here, and then I return 1 plus same function operated on 2, 3, 4, 5. And that same function 2, 3, 4, 5 is going to return 2 plus function 3, 4, 5. And function 3, 4, 5 is going to be 3 plus function 4, 5, and so on. And finally, we will actually just calculate the summation of all this. So this recursion is actually another topic you guys should be familiar with. I know this class is not for these kinds of things maybe per se, but I'll try to spend more time on it and also give you more assignments on recursion, so you'll get more comfortable. So for example here, let's print. Let's say you are confused, and let's print. And I can also tell here print. Hey. Doesn't. Okay. And then print. Keep going. Okay. And here I can also say L is this. So, you know, I'm kind of debugging in a really primitive way, but it should work. So I have this, and then I run this. Okay, L is 1, 3, 4, 5. Keep going. L is 2, 3, 4, 5. Keep going. And then, hey, L doesn't exist. Finally. Okay, so every time it actually calls the rest of the list. Okay, and okay, so this is okay. I already did that. So this was to show you the print. So can we do this in different way? Using so the ternary expression is actually, if you remember from last week, just one line if statement if you want to use. So can we use that? Can I define this function fl using just like single line? Any ideas? Okay, no, don't use. We are still using recursion, okay? If you use, yes, of course you can just use sum to get this. Okay, so what about this? Turn 0. Oh, sorry. Yeah. Right? Do you think that makes sense? Just one line of code. Okay, so let's run this. I hope I didn't make an error. Okay. Ooh. Oh no, sorry, this was something else. So let's get the same list. Sorry, this should be return 0. Oh, right, thanks. Yes, thanks. Yes. Okay. Right? So, if not L, return 0. Otherwise, give me these values. Okay? So this is, we call this ternary expression, which is just like one line. All right, so let's run this. What do you think the result will be with this? Does it work? Remember, you are returning 0 here. And at one point, you will try to add 0 to one of these strings. So does it work? Can you do 0 plus string s? No, right? Let's run. Yeah, we got a type error. Because it tried to implement some operation with between integer and string. So is this clear why that was a problem in this case? Is this clear to everyone? Right? Okay, so can we actually get away from this? If, let's say, if it is a string, let's say we still want to be able to output something. Do you think we can do that?
Return something different.
Right. So what if I type this? Okay. Do you think this will work? So let's run spam. Did. What did I change here? So instead of returning 0, I'm returning as 0 when the length of my array is 1. So that's actually my stopping criteria. Once I have one-dimensional sequence, string or whatever, then I'm returning just as 0. Yeah, but does it still work? I mean, did I lose this one though? Do you think it will work? Do you think this will still work after this change? It does, right? Yeah. Okay, good. So I actually did some error handling here by just changing this 0 with L0, and then it works both for strings and numbers. Of course, if this is the intention in your code, you know, if you don't want to operate on strings, then this is not a big deal. Okay, is this clear to everyone? So when do we need recursion? There are, of course, simpler ways to do these things, and we are probably, so it's probably an overwork to use recursion. But they are usually used to traverse arbitrarily shaped structures. So for example, let's say you have a list, which is list of lists, and you still want to do the summation. So in such situations, recursion can be useful. So let's see what it is doing here. So I'm saying the total value is 0 first, and then for each x in L, so if x is not a list, which means x is let's say number or string, but not a list, then I add that value to the total. Otherwise, run this function on x and keep doing it. So add it to my total only only if the value is, if the type is not a list. Otherwise, recur for the sublists. So let's see what it is doing. And then I have this arbitrary nesting. Oh, sorry, I didn't run it. Yeah. No. Yeah, so this is actually the output, 36. So here it printed these values because I wanted to print everything to demonstrate what it is really doing. So in the first call, it takes the whole L list, this one. And then, so it checks 1. Since it's not a list, it adds to my total. And then runs, works on the rest. Let's see, how can I show that? 1, 2, 3. Okay, so basically for this one, since it is a list, it calls the function again, and then in that function it calls 3, 4 again, and then finally we iterated this part, and for this one it doesn't need to call the function again, but next it will call the function for this one because it's a list too. That's actually what I'm printing out here, but eventually it will actually sum up all the values here. If you don't know the true structure of your list, if there is an arbitrary nesting in your list. Okay, so maybe these are depth first. Oh, by the way. Okay, so I actually want to continue with recursion more next week. So we will talk more about what is breadth first search and depth first search. Okay, so it will be not too much about Python. It will be more about understanding these concepts. But I think they are important. So we'll continue next week. Okay? All right. Thanks, everyone.